you'll be able to understand. So this is also given in your book. This multiplication, binary multiplication, and this one. This is also given in your book. This we saw yesterday. How are two numbers 23 having converted? I think I've forgotten to record, isn't it? We saw yesterday how two numbers are being multiplied. 23 being converted to the binary by means of 84214 and 19 to 84214. I mean, not this column. I think it's not the column. Cell. It should be cell only. And finally, after adding it, how you got the answer, the same as what it should be. Now we are going to make use of the just an ordinary algorithm. This is called multiplication algorithm, that's all. In this case, when you are going to multiply two numbers, you are not going to take the sign of the numbers into concern. The sign of the, just presume the sign of the number, whether it is positive. This is ordinary binary multiplication. What I have explained here, they have given, this is what given in your book. This is what I have explained here like this. I have uploaded this in your classroom. I hope you can understand that. And we discuss the hardware implementation of that. You have here this one. Now what we are going to do now is multiplication algorithm. Then we'll see how this hardware is implemented for this multiplication algorithm. See, in this multiplication algorithm, what we presume here is sign of the multiplier and multiplier. That is the numbers that you're going to multiply. Multiplier and multiply. Can you mean the numbers that you're going to multiply? So sign of these numbers are considered separately. That is the presumption of this very first algorithm. So you're not going to take into account the sign bit at all. You're going to take only the number represented in the form of a binary and not the sign bit. So what we are going to do is we are going to set, initially we are going to set E as 0 and the sequence counter, it's called a C. Sequence counter is the one which counts whether all the process has been completed or not. So sequence counter should contain the number of bits in the multiplier. So if you have 5 bits in the multiplier, means sequence counter should be initialized by the number 5. After that, A should be initialized by 0, not a single 0. You should look into the number of bits of the multiplier. If it's 5 bits, means A should be initialized as 5 zeros. And then what you have to do is the algorithm says, what does the algorithm say? Multiply. If you have the least significant bit in Q, if it's equal to 1, means you're adding B to A and then you're right shifting. Shift right. The SHR is shift right. If you have the least significant bit in Q as 0, means you're just right shifting. This is what the algorithm is saying. You initialize A to 0, E to 0, and sequence counter to the number of bits that's in multiplier. It's what I've stated here. The pictorial representation, I've given it in words. So when you're asked to explain the algorithm, you should write all these in words. Now, what you have to observe is observe the least significant bit in Q. You know, in any number, when I write a number like this, say I write 1 0 0 0 0 0. Now, when I ask you what is the least significant bit, what you should say? Least significant bit is 0 or 1 in this case. In this
0,
case,
ma'am.
least significant bit is 0 or 1. See, girls, having learnt digital paper, if you're not able to say least significant bit means shame on me.
Ma'am, one, ma'am.
Ma'am.
Zero, ma'am.
Least significant bit is one. You got confused. Least
One,
significant bit
ma'am.
zero. Least significant bit is zero. One is most significant bit. Zero is least significant bit. This zero. This zero is least significant bit and this one is most significant bit. So what is your observation is once you're going to do the product, I find the product of two numbers, multiplier and multiplicand. You're storing the multiplier in Q and multiplicand in B. A is the accumulator where you're going to store the results. So A should be the number of bits 0 as it is in B. Now least significant. What you have to do is once you do one step, you should observe what is the least significant bit in Q. If it is 0 means what is that action that you have to do? If it is 1 means what is the action that you have to do? That's what is mentioned in this flowchart. Observe the least significant of Q. If it is 1, add the value of B to A and then right shift. If it is 0, just right shift. That's what. So what we are doing, that's what I written here in words. You are looking into the least observation, observe the least significant bit in Q. If it is equal to 1, what's the action that you have to check? If it's, you're observing and you're finding whether it's 1 or 0. And after observation, the action that you have to take. It's equal to 1, add B to A and right shift. Action, if it's equal to 0, just right shift alone. What we saw in the flowchart, I'm giving here is in the form of words, written explanation, that's all. That's what is given in this flowchart. And when you should stop, you have initialized and you're beginning this, you're starting to find the product of two numbers. When you're proceeding, you should know where you should stop. We said the serial counter has to be initialized with the number of bits in the multiplier. So if the number of bits in the multiplier is 5 means sequence counter is initialized to 5. So as you keep on processing, the sequence counter will be decremented after every process. When it reaches 0, you're doing on this process, you're observing the least significant bit in Q. If it is 1, you're going to add B to A and then right shift. If it's equal to 0, just right shift without adding B to A. And you're observing the sequence counter. When it comes to 0, the product is finished. That's all. You have found the answer. That's the end result. You can stop further processing. That's what we are going to do now. Now you have the multiplicand, two numbers that you are going to have, multiplicand and multiplier. The same 23 and 19 we have taken. Say B is having 23 and this is 19, this Q is 19. So I have written Q here. So first step, see, follow me carefully. To begin with, we said A should be initialized to 0 and E should be initialized to 0. A should be initialized to the number of bits in the multiplier. Number of bits in the multiplier is 5. So you're initializing A to 5. And the sequence counter should be initialized to the number of bits in the multiplier and is initialized to 5. Is the first step clear? Shall I proceed further? See, listen closely, then only you'll be able to understand, otherwise you'll understand nothing. Shall I proceed? Is my first step clear? Two numbers multiply. Two numbers multiplier and multiplicand are here. So multiplier is here, multiplicand is here. You're observing what we said is observe the least significant bit in Q. So I've given the least significant bit. there a noise disturbance, girls?
Yes, ma'am.
Is there noise disturbance?
Not now, ma'am.
Yes, ma'am.
What we are doing here is the least significant bit in Q is 1 that I have mentioned in the form of red color. So it is 1. So what we have to do? We have to add B to A. So we are adding B to A. Once you add B to A, you get this. After this, what we have to do? We have to right shift. So when you're right shifting, it will give you these also. So that's what I've done the right shift here. I've explained right shift here. The number here is 0. I've taken this here. See, right shift of 1011100011. So I've taken this number. And when I right shift that, 0 is also taken. 0 will come here, 1 will come here, this 0, this one, this one, this one will go to Q. This one, this 0, this 0, this one, and this one is dropped. This red color, what's given here is dropped. So the final right shift what you have here is all this 01001. So this is we have done one step. We have checked what is the least significant bit in 1, least significant bit in Q. We found that it is 1. So we have added B to A and we have right shifted. One step is over. The sequence counter is decremented. So drop the least significant bit after right shift as it is started from E. That's what. Here this one is dropped, no, that's what I have given here in remarks. Then second step. Then we have to observe here. This is the sequence counter and it's 4. Here observe the least significant bit is 1. Again what you have to do, you have to add B to this. Again right shift. So that's what's done here. Observation least significant in Q is 1. So action is add B to A. So in this case, you're getting a carry. When you're adding, you're getting a carry. So that carry is in E. This is your addition. With this, the step is not over. You have right shift. This number after right shift, you get this. So the sequence counter is now decremented by 3. By 1 and it's now 3. And I've explained here how the right shift is done. Right? This is the number, how this right shift is done and how you're getting this here. I have explained here. Right shift means just you're doing this. This is not right here. You won't get 0 here. When you're shifting right, there will not be a 0 here. So this is the way. The step is over and you're in third. Sequence order has come to third. Then you have to observe here. Here the least significant bit is 0. In this case, you have to just right shift. So you're just right shifting. And you're getting the next. Next you're decrementing the sequence counter to 2. Again you're going to right shift. Since you have a 0 here, just right shift. So observation least significant Q is 0. So action right shift. So you're having a right shift. Now observe here. It is 1. So if it's 1, you have to add B to A and then right shift. So you're adding B to A, then your right shift. And finally, you're getting this answer. Now check whether this is equal to the product of 19 and what's the other number? 26 or what's that? 23, I think so, isn't it? 19 and
23.
check whether you're getting that product. Check this number. Now the sequence counter has reached 0. Now we can stop here. This is multiplication algorithm. See, you will feel as if you have understood. Now I will give you, now it's 11:30. I'll give you 10 minutes. Go through this algorithm again. Check whether you are able to visualize what I'm saying. I worked out this. I worked out in such a way that it will be understandable to you. Here it will, in your right shifting, you don't have the zero shifted here, so you don't have element here. Yes, this is correct. So I have uploaded this in your classroom also. So you take this, start from the first step, check whether you're able to do this. Only then you can understand what's given in your book. I'll give you 10 minutes, girls. Shall I stop sharing? Because I do not know who is following which step. I'll stop my sharing. So I'll give you 10 minutes. Go through this, whether you are able to work out this or not. Only when you understand this, next we are